Hello. The following videos are prepared for students to review for the logarithms test coming up on February 11th and 12th. These problems are the same problems on your study guide. I've just spread mine out a little bit more to make room for working them right here on the page. If you don't have room on your page, be sure and add some extra paper. And remember, I will collect these in their entirety on test day. So do complete each and every one, showing all the steps. Looking at question number 1, it says to find the domain of the logarithmic function. One of the ways you can do this is to look at this piece, and this is going to be the log. But perhaps the easiest way to do that, since you can use your calculator, is to graph this in the calculator. So you would graph y equals ln of 8 minus x. And you'll see when you graph this that there is a relationship between what's in the parentheses here and your graph. So this one's going to come from negative infinity, and that's because of the negative x. And it's going to go to positive 8. And you can see right here that this is 8, so it's going to go right up to 8 but not include 8. So one of the things you could do is check your table. And as we've said in the past, looking at your table might be helpful. So it does go to 8. If you are confused about that, remember you can look at the table set and take this to ask and then quit. And our table is going to include values of, say, 7.9. There will be an output. So if you're not confident as to whether it goes right up to 8, be sure and use the table. So using the calculator here, we have from negative infinity to 8. And they're both rounded because, as you saw on the table, the 8 was an error. So again, to recap this one, as we looked at our calculator, goes from negative infinity to 8, and we're looking at the graph. And this does not include the graph. 8 does not include 8. But goes right up to 8. So you have to include 7.9, 7.88, and so forth. Likewise, in number 2, you're going to be looking at the calculator, but you should take a hint for this one. This one is going to go from negative 8, because you remember the domain for log only starts at 0, and so if we add 8 to that, negative 8 plus 0 is going to be what we're going to look at for that one. And it's going to go to infinity. But you can see that also in your graph. So let's take a look at the graph for that one. Negative 8 to infinity. So looking at the graph for that one, let's graph y equals log base 3. So let's clear this one out and let's do it's alpha f2, and that's number 5. Alpha f2, number 5, and we want log base 3 of x plus 8. And we want to graph this. So again, looking at the graph, it starts over here, and you can count these and see that it's -8, but you could also look at your table and see what numbers to put in. So you can see that 7.9, so we think it looks like -8, so let's put in -8 and graph, and you see that's an error. So if we put in -7.99, you're going to get an output. So this does go right up to 8, and it has outputs for all of these numbers in between there. So moving on to question number 3. Use the properties to condense. So this is an adding one, and this really is just kind of remembering this. This is going to be log base c of m times n. And so it's a multiplication. So this is what we call the product rule for logarithms. And I know your page doesn't flip now, but I did spread my questions out a little more. So on to question number 4. We're supposed to condense this. So this one will be log base y of 4 times 2, and 4 times 2 is 8. And so we're going to go ahead and multiply those two numbers together since they're numeric. Okay, in number 5, there's actually 2 rules here. We have the product rule, so we're going to go log base 8 of x and y, but you see that there's a 1/2 in front of the one with the x, so this has to be to the 1/2 power. And another way to write that would be log base 8 of the square root of x times y. And some people like to write the y in the front because then it doesn't give any indication of the y being under the radical. So you could just write the times y here and be done with it as well. Okay, number 6. We're supposed to solve this expression and leave our answer in terms of natural logarithms. So the directions are like this so that you don't have to necessarily use your calculator to do that. So what we're going to do is the logarithm piece, and remember this is going to be log base 3 of 4 equals x plus 6. And I think I'm going to change my mind here and use that e to the power that we did once or twice in the past because I have an exponent here. Okay, I'm going to take the log of both sides. So the log of 3 to the x plus 6 equals the log of 4. And so the power rule says that we're going to bring this one to the front. X plus 6 times the log of 3 equals the log of 4. So I'm going to divide both sides by the log of 3. So x plus 6 equals the log of 4 divided by the log of 3. And so now I'm going to subtract 6 from both sides. So x equals the log of 4 divided by the log of 3 and minus 6. And again, we could calculate this with our, write it as a decimal with our calculator, but it says to leave it in terms of the natural log. So this is the exact answer that we'll work with. Okay, and number 7, again, I'm going to take the log of both sides. So the ln of 4 to the x plus 4 equals 5 to the 2x plus 5. And you know that you need to take, the log of 5. Let's fix that. You know that you need to take the log of both sides when you have an exponent with a variable in it. So that's kind of your clue as to when to use that strategy. The log of 5 to the 2x plus 5. So using my exponent rule, x plus 4 times the log of 4 equals 2x plus 5 times the log of 5. So remember, I want to get the x's on the same side, so I'm going to divide both sides by the log of 4, and I'm going to divide both sides by 2x plus 5. So I get x plus 4 over 2x plus 5 equals the log of 5 divided by the log of 4. So going to your calculator now, you can see that we're going to do the log of 5 divided by the log of 4. And don't forget to close your parentheses because that will make a difference. So the value of this is 1.609. And notice I went an extra digit. It does say to go 2 digits. Well, actually, I think this one said to leave it in terms of log. But we're going to go ahead and turn this one into a decimal. And that's fine for you to do as well. So this is going to be 2x plus 5 times 1.609 equals x plus 4. And what I did was cross products. I had this equal to this and kind of put this over 1. So now we're ready to do our multiplication. So 2 times 609 is going to give me 3.12. So up to here now, I'm going to get 3.12x plus 128. Let's go one more digit. Plus 5 times 1.608 is 804. So this one's 804. And that's going to be equal to x plus 4. So if I subtract 8 from both sides, 3.128x equals x plus 4 minus 8.04, and I get negative 4.04. Let's make that so you can see it. Negative 4.04. Now I'm subtracting x from both sides, and 3 minus 1 is just 2, so it's 2.128x equals negative 4.04. So now I'm just dividing negative 4.04 divided by 2.128, and that gives me negative 1.898 And so this is going to go up to negative 1.90 if I'm rounding this to 2 decimal places. So you do remember we did one homework question like this one that was very, very detailed, and you had to use the cross products. So we're going to stop this video and continue with part